Welcome to Ultimate RC Events Push the Limits. This is our build series about our boats, all sorts of videos about how we built it, each aspect of it. This video is about the hull in particular. For some people this video will drag on and be a bit boring if you already know or have this knowledge, but if you don't, hopefully you'll find it really interesting and an insight into what is the extreme world of radio controlled boats with this one. So enjoy the video, hopefully make it to the end, give us a like and subscribe, and look out for further videos as we get into the build of Push the Limits. Okay, the not so pretty part of these boats, the underneath, the bit that isn't shown lots. I tried to find footage of the underneath of these boats lots of times, and unfortunately no one's is explaining them or telling you anything about them. The boats have a centre of gravity known as the C of G or centre of gravity. So that centre of gravity is halfway between the steps on the hull. So these are the steps. There's a step, and you're at the back. The centre of gravity on this hull is between step 1, step 2, so it's about there. So when we're getting this boat balanced, and by the way, when you're making the decision to put all your gear in, you need to mock up. You need to put all your gear in, not fixed, not glued, nothing. You need to put it all in, batteries, everything that's going to go in, to see if you can get the thing to balance here. So the centre of gravity halfway between step 1 and step 2 on these hulls, and most catamarans, regardless if it's smaller or bigger, the centre of gravity is normally on these designed hulls in the center there. Now you can play with that center of gravity. That's going to change the angle of your boat, and we do that with our batteries. We move our batteries forward of the center of gravity or back from the center of gravity. When I design this boat and it's flipped over, the batteries are sitting just forward of the C of G here. I can move them back and I can move them forward to change my angle of attack. So first thing that was actually really hard to find out, where's the center of gravity on the boat? So these boats effectively fly. So if anybody doesn't realize this, they sit in the water, but at speed, they're flying. There is an airfoil section we'll go into in a little bit more with the boat in a sec, but center of gravity is really important to get right because that'll stop your boat flipping or trying to mow into the water the whole time. So again, setup's very important for that. What are these steps? Some people don't know what the steps are and why they exist. You're trying to get a hull like this to get out of the water, get away from the water. You want it to fly. You want the thing to literally just about fly on the propellers. And if you just have a straight hull all the way along, no stepping, no nothing, all these things are really nice, glossy surface, all the rest, it's going to stick to the water. It's going to hold it. Water actually holds a lot of traction. So it's going to stick along the water. So what happens as the water runs along here, comes to these steps, it can't transition down that step. So air bleeds in here. Air comes in here, and as the water comes over, it breaks surface tension and steps over and mixes with air. So now you have an air and water mix coming through here, a lot less tension on the hull, a lot freer. The hull will plane faster, go faster. So that's what the steps are there for. The other thing that's done on here, it's probably hard to see and it's a bit dirty under here, my fingerprints are on here. But when I got this hull, this is the original gel coat that's on the hull. We haven't painted the bottom. And the reason we don't like painting the bottom of these is if you do, you may lose these nice sharp edges here and here. These things here along here are called chine rails. So they help the boat track really nicely without sliding in the water. They allow it to track, as much as they also create lift. And the way they create lift is they change the direction of the water. So as the water comes on a V, so this is slightly V'd, as the water breaks off here, comes down, it then gets kicked up. That creates lift. So that may be hard to explain. I'm not going to go into major depth about it. But here and here creates a lift on a hull, and that's how the water allows lift. But it's really important that these edges are as sharp and nice as possible. And the problem is when when you sit there spray painting one of these, the paint tends to curve over these. So this is the original gel coat the boat came with, which is why it's not pretty. It's why it gets dirty. It looks like it's scratched in areas. It's not. It's actually been sanded, block sanded, to gently get these edges sharper. The other thing is that you do to these hulls is you cross, what they call cross hatching. So if I've got that correct me if I'm wrong, but I know it as cross hatching, which is to put sandpaper, take the gloss off this. So you'll see here's a little bit of a gloss. I could do this a bit better. So I get a block sander of about 600 grit or 800 grit sandpaper, nothing too coarse, and I sand it that way, and then you sand it that way without taking the edges off this. You give it a sand that way and a sand that way, and you create a cross section of little minute scratches in the hull. And by scratching the hull, as the water hits it, the water doesn't stick to the hull. It creates less surface tension. The same as these big steps do. The slight sanding and scuffing of all of this creates that roughness. Now, because this gel coat here isn't in the water, and it's in the air effectively when the boat's running, that is still the original gel coat. Whereas if you come up to here, and you can just see in the light, just there, you can see the scratching that's been done with the sandpaper to get that surface tension down. So we want to get that nice and down and allow the boat to go fast. Now, back end's not pretty. This thing's had a few modifications done. So there's the hull and the prep work that goes in the hull, and I could still do a bit better. I can see areas doing this video where I've still got a bit smooth, and I could get it a little bit better and really trick the hull up nicely. So let's come back to the drive units. Previous video, I was running MHZ drive units. Fantastic units, the MHZ drive units. There is no problem. They've held the boat up for its first runs, 154 kilometers an hour. We could have pushed that even harder. But with the MHZ drive units, so they're fine. The drive units, and what I'm talking about there is from just here, the back of the transom, back of the sponsons. From here back along here, and the drive units are off this at the moment. They're just sitting up here. They've just been serviced and fixed up. These are our new drive units, the brand new custom carbon fiber parts drive units. I'm going to keep this basic. They connect to here. Bolts go through, connect, or bolts come in this way, connect. Each drive shaft's a bit different, but let's just go to the principle of how they work. From this part, you've got your shaft and your flex drive, which if you're doing model radio control boats, you've seen this. This is just a lot bigger. So really big flex drive, quarter inch flex drive onto the actual drive shaft with our prop shop 3-blade propellers, which we've also got some other propellers, but that's the current ones we're running. That whole unit slides in there into the stuffing tube, which is in the boat, and you're locked in there with the drive shafts. But where do you locate the drive shaft? What angle do you run the drive shaft? What height do you run the drive shaft? It all makes differences. So the key to any tunnel hull or a hydroplane or anything like that, or a fast boat, so something you want to drive really fast, is you want to get the props. These are called surfacing propellers that we use. So they're designed to actually run in the water, out of the water, in the water, out of the water. So they're surfacing. They're actually meant to come to the surface. You've got underwater propellers, and they'll generally sit back under the hull. These are surfacing propellers, generally down the back of the boat, allowed to surface. So the drive shaft needs to be, as much as you can, lined up with the tallest part of the hull, which on a catamaran is obviously just here. Then the tallest part comes down the taper. So you're trying to get your shaft pretty much as high as possible. So as they go along, if I was to put a ruler, which I can do, just grab a ruler. Alright, and I've only just rammed these shafts on, so they're not going to be lined up properly. But if we run a ruler along there we go. We get right off the bottom of the hull a pretty good lineup of the propeller and shaft all sitting around the tallest part, reasonably parallel. You're never going to get it exact because you can't literally put the shaft protruding up here to get it in line, because then you'd have water hitting it. That's obvious. I would have thought it was obvious anyway. But you're trying to get the shaft as close to this tallest part, because the boat's going to be running in the water here, and then not down here. This is all airborne. Hopefully, if you're going that fast, the water's pretty much around here. So water's coming along there, touches these. These don't want to disturb the water too much, but that flat edge will act as a bit of a surface to plane on. Then it's hitting your propellers. It's actually your propellers that start doing all the work in regards to lift and push and all that, and it gets quite technical. So just here, you've got the standoffs. They are adjustable because you can change the angle of attack. If I raise these shafts up like that, that's going to lift the back of the boat, up, which is actually going to plough the front more in. Or if I go down, bring these shaft angles down, I'm going to lower the back of the boat and raise the front. Just keep these neutral for now and change the battery's center of gravity, and we can keep the boat running as flat as possible. So if it does what you want the boat to do at high speed, if it does a jump, you don't want it to jump and pitch. You don't want it to pitch that way. You don't want to pitch that way. You want the boat to jump, fly level, and land. So keeping these as neutral as possible is probably a good way to do that, because if they're pitched in any way apart from neutral, and neutral is running along this hull with that ruler and keeping them as level as possible, if they're pitched in any way, the boat will, as it takes off and wants to land, the immediate pitch in those shafts will change the angle of attack of the boat. Now we've got a boat that's wanting to porpoise, get airborne, do all sorts of funny things. Again, we want it to jump. If it's going to hit a wave and get airborne, we want it to jump flat and then just land straight back in and keep going. We can maintain speed, go even faster, because they are basically airborne when they're running, and they will jump slightly as they're running. So this is really important and an area to play with. Now, if we put a ruler along the sponson and coming out, get that ruler lined up, there we go, nice and parallel. I don't know if that camera's picking it up, but we want that to run nice and true with the water direction, and that's important to get equal on both sides. So everything that's done to this one has to be exact on this one. And the hull mold, when the boat comes out of the mold, it might be slightly out, might be this one, might be, but you, at the end of the day, the water channeling down here and channeling down here at speed, these can't differentiate, or else you're going to have a boat that starts doing some weird things. It might zigzag, it might do all sorts of things. But scale speed at this boat at 200 kilometers an hour is ridiculous speed if you scale it up. So it's really important to get these things correct. And we're still playing with them. Every hull will act a little bit differently. So once you've set it and then you go to run it, it may actually perform slightly different. Rudders, not a lot to say with rudders. So the biggest misconception is you get a big boat like this, and a lot of people love the aluminium. They go, oh, gorgeous, I'll polish that. No. Don't polish it, scuff it. So you want this the same as the hull. You want it to be roughed up a little bit so it doesn't cause surface tension. The other thing is they're normally a wedge. So you can see it's actually wedge shaped. You want to check that wedge is equal both sides, because just like aerodynamics, water dynamics will create a lifting side of this rudder. And rudders can actually create, when they turn, they can imagine getting a ruler. There we go. So I had it handy. Getting a ruler and swishing it through your bath and then turn it, or want to turn. But if you angle it slightly and then turn it, when that's going through the water, the rudder will actually want to lift the back end of the boat. And if you turn that way, the rudder will actually lift. So having the rudder sit nice and true when it turns, that'll want to change direction and not lift. So some people do that on purpose. Some people in their race boats will actually make the rudder taper slightly to do it. And that just frees up the boat a little bit on turning. If it's a circuit boat, this is really important. If this is a speed machine, not so important. So we just want that rudder pretty much straight up and down. Last thing, if you've watched my previous videos, I got lazy with the steering. I ran 2 cables straight through here and said, yeah, that's great. It was horrible. And you'll see in the previous videos, I had a lot of problems with parallel lines running and offset leverage. And look, have a look at the videos, it'll muddle up, but this is the way to do it. You run a V system. We're currently repairing one after the run. There's another one here. And then that becomes one-to-one turning. It makes its way through here. There's a cable connected. That cable runs through a sleeve, goes back, and then it angles back there. You turn. Anybody understands your triangles and everything, and leverage points, fulcrums, if you want to get really scientific. This is a hell of a lot better way and a lot more stable way of holding that rudder nice and true, and not having any issues. So there we go with the steering. The rest is pretty basic. Bolt in both sides. Okay, last thing under the hull, water pickups. Another thing I wasn't sure of. I've done water pickups. A lot of my boats, and a lot of you guys may have boats that the water pickup is back here on the back of the transom. Water shoots in, picks up. You can have in hulls. I wanted something that wouldn't disturb the water flow as much, but would still obviously pick up. Yes, they're rough. Yeah, they don't look pretty. They're not about being pretty. I don't want them pretty, because I want all this rough and looking so the water doesn't stick around here. It just goes in those chambers, picks up what it needs, and the rest gets off there real fast. We don't actually want water sticking. We don't want the back end sticking, as I've just discussed. So twin water pickups on this boat. Some would argue that could drag. I don't know how much drag they're creating. They'll definitely be creating something because they've got to pick up water. To be honest, my water pickups at high speed probably don't even work that well, and nor do they need to. I'm on a speed run of only, well, not even a second long when I'm absolutely hiking, and the temperature that's built in the system, these don't even need to be picking water at that point. They just need to be, when I slow down, you'll notice after every big power pass I make, I slow down. It's not a circuit boat, this is a speed running boat. So I slow down, that puts the hull back in the water, which drowns these, which puts a lot of water in those pickups, and then they start exiting, which there's the exits on that side for those two, and the other side has exiters on the other side. One final thing I've got to say about the hulls is I did mention aerodynamics. These hulls are actually an airfoil section. They're curved, so as much as there's a lot of water dynamics going on here, if I come down low here and we look right there, it's a flying wing, and I'm talking about here. This section here, up here, curved, down here, curved as well. This section is a flying wing. So generally speaking, it'll be what they call an asymmetrical wing. Won't have lift either way. And some will have lift. Now, from what I can gather with the MHZ 1890, my boat, it has a slight bit of curvature. If you look down along there, it curves slightly that way, and it's definitely on the top of the hull slightly curved, so it's probably creating a slight bit of lift as that section goes through the air. So it is literally a flying wing. Once we get all the water off these babies, this whole section here is a flying wing. It's a whole wing foil section to create lift. Again, gets a bit more technical in that area, but hopefully that, if you didn't know that, that is, you know, that's another part of making these things go fast and understanding how they do it. Hopefully that gives you the basic understanding of the drive units, how they're put on, the standoffs, all the rest. If you're building one of these, we're happy to help you. We'll get more into the rest of the build in the next videos.